Hello! In this video, I will be talking about a stream's components, how streams affect other ecosystems, and how humans impact streams negatively and positively. I will go into depth on how living organisms within a stream affect it positively and negatively. I will cover how a stream is formed, and I will also talk about how pollution can affect the life of a stream's ecosystem. Enjoy!
Many living organisms that live within streams and outside of streams depend on them in many different ways. Streams are divided into three different zones, Zone 1 being the headwaters, Zone 2 being the transfer zone, and Zone 3 being the depositional zone. In Zone 1, the headwaters zone, mountain headwater streams flow down to cut a V-shaped valley. In Zone 2, the transfer zone, low elevation streams merge down and flow down gentler slopes. As the valley begins to broaden, which leads into Zone 3, the depositional zone, a nearly flat valley is created. At its mouth, it is divided into many separate channels. Once we begin to look at streams in depth, we see that they are formed from excess water from rain, snowmelt, or near-surface groundwater. This excess water generally occurs when the water accumulates at a faster rate than the soil and organic matter can absorb water. Once we begin to look at the stream's components, it seems very complex, but is a lot more simple than you think. At the left side, there is the floodplain, the left bank, and the terrace. The right side of a stream, we see the right bank. This is from the perspective of looking at a stream downstream. At the bottom of the stream is the stream bed, and in the middle is the thalweg. The thalweg is a line upon a topographical surface which is a natural watercourse, having everywhere the direction of the greatest slope and distinguished by having the lines of a straight horizontal projection which cut at right angles on the upper sides of the curves of equal elevation to which they are tangent, or a line that defines the lowest part of a stream. In most temperate streams, the temperature ranges between 0 to 25 degrees Celsius. On the other hand, desert streams can reach up to 40 degrees Celsius. Seasonal changes do affect the climate, but during the winter, the temperature rarely falls below 0 degrees Celsius. This is because air temperature hardly affects the stream through convection, but the main heat input to the streams is solar radiation. When we look at a stream corridor from a lateral profile, it is very easy to distinguish the subdivisions of a stream. In a channel or a slough, we see that it is very popular for fish to live within those subdivisions. At a more broader perspective, we see that within a floodplain there is a floodplain lake, the natural levee, a slough, and an island. Many plants usually inhabit a floodplain lake and a natural levee. A few common plants that can be found within streams are coontails, waterweeds, pondweed, and water chestnut. Some animals that live near rivers and search for prey within or near rivers are mud crabs, turtles, bald eagles, and beavers. The vast majority of drinking water is accounted from streams, especially in the United States. The streams that account the most drinking water are streams such as seasonal, rain-dependent, and headwater streams. Porter County gets 0% of its drinking water from streams, but Lake County gets 21 to 50% of its drinking water from streams. Streams end up interacting with other ecosystems quite often because of what can be carried within the stream. Wind can blow sediment and pieces of organic matter into a stream. Many animals can die adding organic matter into the flowing water. There are many different life forms and living organisms in streams such as plants, diatoms, fungi, larvae, and crustaceans. Diversity must be prevalent in order to maintain a balance within this ecosystem. The keystone species have functions that correlate with other animals in this ecosystem that without them, the whole ecosystem could collapse. An example of a keystone species is the beaver. The beaver builds dams which can slow the stream, and this benefits the water quality. This also makes it so organic matter can mix together and makes it easy for fish to mate within the stream. A very popular fish living within these streams that is not native to the United States is carp. These fish root within mud looking for food. They constantly go within different soil types, clay being the most common, and silt, which clouds up the river. This can negatively affect many living that are reliant on sunlight. Many plants die, killing off a resource of food for other animals, resulting in those animals' deaths. There are many living organisms within the stream that negatively affect the ecosystem, but humans also have a negative impact. Air pollution is a very large problem that is prevalent within the stream's ecosystem. Acid rain is formed from air pollution, which causes minerals to mix within the stream. A very deadly mineral within the stream is aluminum. This aluminum builds up together and grows within the streams. Many fish, especially salmon, have a buildup of mucus from this aluminum to the point where it is impossible for these fish to live. They slowly suffocate and die. On the other hand, while these salmon mature at sea, they accumulate marine nutrients. When they return to fresh water to spawn, they transfer the stored biomass to the stream habitat. The decomposing carcasses contribute food to the entire ecosystem, spreading nutrients throughout. Streams have many important aspects that actually help the world. Fishing is affected when many salmon die because of air pollution, and migratory birds depend on healthy wetlands. Throughout the good and the bad, streams are here to stay to affect other living organisms directly and indirectly. Whether or not we want streams to affect living organisms positively or negatively is up to humans to modify the ecosystem in a way that will affect other living organisms in a positive manner.